Hey guys, we're going to try something a little bit different today. This is going to be a video lecture, so this will be playing while you're taking your notes, and I will be walking around the room, checking on you, making sure that you're not lost or confused. For this to work, you have to be quiet, you have to pay attention, and you have to listen to what I say. I will only play the video once, so if you miss it, then sucks to be you. I will highlight everything that I'm talking about or use my laser to kind of, get you to see what I want you to write down, and I've tried to color code what you need to write down on the note, so it should be fairly simple. So we're still talking about sig figs, but this time we're going to be talking about specifically Rule 4, the one that says that numbers in front of times 10 to the whatever number are significant. So here we go. Okay, so why do we even use scientific notation? Well, it's a really easy way to write numbers that are very, very big or very, very small. So that's what I'd like you to write, please. Okay, so again, you're writing what's highlighted in yellow. Scientific notation is a way to easily write numbers that are large, so big, or small, little. When you see a number in scientific notation, don't think it's like a math equation or something. It is just a different way that we use to write, again, really large numbers or really small numbers. So there are always going to be two things that are true for a number written in scientific notation. This should be the next section in your notes. There is always one, just one, non-zero number in front of the decimal. So that number could be 1 through 9, but it's not going to be a 0. That's the first thing that's always true for a number in scientific notation. The second thing is that the number is always multiplied by 10 to the power of something else. Or in my notes I have it as 10 with a little superscript b. The b represents an integer, and an integer is a number that is not part of a fraction or a decimal. So 10 to the 5, 10 to the 6, 10 to the negative 28. All of those would be examples of integers that we would write off of the 10. So again, two things are always true for numbers written in scientific notation. There is always just one non-zero number in front of the decimal, so the rule written in green, and the second is that the number is always multiplied by 10 raised to another number, and that number will never be a fraction and it will never be a decimal. It's always a whole number or an integer. Okay, there is an example on your note sheet, and it says circle the numbers that are correctly written in scientific notation and place an X over the numbers that are not. So I've circled 3.5 times 10 to the 16, 2.44 times 10 to the 21, and 1.34 times 10 to the 14. All of those are correct because the number in front of the decimal is a non-zero number and there's just one of them, and everything's written raised to the power of a whole number. So 10 to the 16, 10 to the 21, 10 to the 14. So you should have these circled in your notes now. The ones that have an X over them had something wrong with them, like this 10.7 times 10 to the negative 24. This back part's right, but remember the first rule says that it'll only have one non-zero number. Well, there are two numbers here, and one of them's a 0, so that one's not correct. So just for an example of why it's not right. There is no place for you to write down what you're currently seeing on the screen. I just wanted to give you an example of what we mean when we say integer. So again, I've circled the ones that are correct, and it's because all of those numbers are whole numbers. They're not fractions, they're not decimals. So like 10 to the minus 21, 10 to the minus 11, 10 to the 14. The ones I've X'd out are the ones that are incorrect. So like this one was 1.5 times 10 to the negative 1.6. 1.6 is a decimal, and we never write decimals when we're writing scientific notation off of the 10. So that's why that is incorrect. All right, so here's the same example that you have on your note sheet, and I want you to look through and circle the ones that are correctly written and put an X over the ones that are incorrectly written. I'm going to give you like 5-10 seconds to do that. All right, hopefully you're done. We're going to go ahead and move on to the next slide. So you may have noticed that some of the numbers off of the 10 are positive and some of them are negative. Those numbers, by the way, are what we call an exponent. So the reason that some are positive and some are negative has to do with how we move the decimal point. It also has to do with if the number is just a really big number or a really small number. So whenever you have a positive exponent, it means that the original number was really, really big. In other words, the zeros were behind the first set of numbers. Okay, so go ahead and write that down for what does a positive exponent mean. Now I kind of flip-flop this on your notes. The next question, how do we figure out the number that is written off the 10? That's actually going to be answered on the next slide. So go ahead and skip down to the question that says, what does a negative exponent mean? Well, it's kind of the opposite of a positive. A negative exponent means that the number is very small. So the zeros come in front of the whole numbers, and there's going to be a decimal point. So that's how you know if you're dealing with a positive number or a negative number. If the number is large, which means the zeros are behind the whole numbers, and there is no, well, not necessarily a decimal point, then it's a large number. If the zeros are at the front of the whole numbers and there is a decimal point, it's a really small number, it's going to be negative. Okay, now we're going to go back to that question that we skipped, the one that says, how do we figure out the number or integer that is written off of the 10? Well, we're going to count the number of times the decimal point moves. Now remember, when you have a really big number, technically behind that last digit, there is a decimal point. So that decimal point would be right here in this case. So we're just counting how many times we pretty much jump it or move the decimal. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. It took us 9 movements to get the decimal from the back of the numbers until it was between two whole numbers. Okay, so that's how we get 10 to the 9, because we moved the decimal 9 times. And it's positive because this is a very large number or a very big number. Now on this slide we're showing you pretty much the same thing, except this time I want to show you how we get negative numbers. So again, that's when the number is really small, which means the zeros are in front of the whole numbers and there's a decimal point. We're still counting how many times we jump the decimal or move the decimal. So the decimal starts off here, right between these two zeros, and we're going to move it 1, 2, 3, 4, 5, 6, 7 times, so that it's between this 1 and this 2. So that's how we end up with the negative 7. Now most of the time that you're doing scientific notation, you're going to be putting these numbers into your calculator. So it's important that you know which buttons on the calculator you're going to press to get the right thing. So we're going to walk through the 4 steps of how we put numbers into, or how we put scientific notation, into the calculator. Okay, the calculator that I'm showing you, this green one on the screen, is the same blue ones that we have in class. It's just a different color. So we're going to try to put in the number 6.02 times 10 to the 23. Okay, that's our scientific notation that we're going to try to write on the screen. So you need to write the steps down. Here we go. Step 1 is put the first number, which is called the significand, into the calculator. The first number is going to be that 6.02. Okay, so you're putting whatever comes in front of the multiplication sign into the calculator first. Step 2 is press the second function key, and step 3 is press the x to the minus 1 key. Okay, so we're doing second function and then x to the minus 1. So those are step 2 and step 3. Step 4 is type in the exponent. So you're not going to type in times, you're not going to type in 10, you're going to just type in 23. By pressing second function x to the minus 1, that took care of typing in times 10. So you don't have to do that again. Your last step is just to type in whatever that exponent number is. Okay, now when you type it in, this is what it's going to look like. 6.02 E 23. The E represents times 10. So instead of just writing times 10, they just use an E symbol for it. But it's the same thing as saying 6.02 times 10 to the 23. Okay, so this is the calculator version, and this is the version that you actually have to write down. Okay, now on your notes, you have the exact same images that I have up here on the slide. So 3.01, E24, 1.51, E24, you get the point. I want you to rewrite those in scientific notation. So replace the E with times 10 to the whatever. So go ahead and do that, and as soon as you're done, I'll give you more instructions.